Hello, I welcome you to this presentation. This is video 1 of unit number 3 in our series of videos on the use of CPN tools software. In this video, we will be discussing the use of time in color pertinent models when such models are implemented in CPN tools. In this video, we will cover timed color sets, time stamps on tokens, and concept of an event clock or a simulation clock as they are implemented in CPN tools. And as always, we will discuss all these features with the help of a very simple example CPN net model. In a timed CPN net model, tokens must have a token color, and we have seen how those colors are defined inside color sets, but it must also have a time stamp. A time stamp is a non-negative integer. For those of you who have been using versions prior to 3.2.1, the stamp on a token, time stamp on a token, was supposed to be an integer, a non-negative integer number. But the most latest version, the one that hopefully you will be using, version 3.2.1, allows real stamps as well. In order to use real stamps, you have to go and set an attribute which allows CPN tools to run with real numbered timestamps, and we'll see as to how that feature can be set or reset. The timestamp tells us the time at which the token is ready to be removed by an occurring transition. So if you see a token with some color, some value, and a timestamp, the purpose that this timestamp serves is the time. It tells you the time at which this token will be available for transitions to get enabled. If the token is in an input place to a transition, that is the earliest time when this transition can remove this token. The syntax of our tokens with timestamps will have a syntax like this one. So we'll have one backtick E, where E is some color on a token, and then we'll have this special character add, and then followed by a plus sign, and then an expression that evaluates to integer if you are using an integer stamp, or it should evaluate to a real value if you are using a real stamp. Some examples. So we have a token over here. Capital A is a token color. So what you see over here is a token A which has a stamp of 5, an integer stamp 5 on it, which tells us that this token A will be available at time 5 for enabling transitions, and transitions can then remove it if it's in the input place. Here is another example of a multi-set of tokens. Multi-set, we have more than one token in this example. So the first token is still A. It is available at time 2, and then we have 2 plus signs, which is the notation we use for multi-sets. The other token B is available at time 5. Similarly, we have a token from a product color set where the token color is of an ordered pair type. The first element is A and the second element in this ordered pair is B, and this entire token AB, ordered pair AB, has a timestamp of 20 on it, which means that this token AB is available or will become available at time 20. When we say this becomes available, there must be a reference clock that we look at while determining whether a token is available or not. Therefore, we have this notion of a global or event clock that represent the model time, and every token's stamp will be compared with this event clock to determine if that token is available or not. So for example, if the global clock says 0, none of these tokens that we have seen in these examples will be available at that time. When the clock time reaches, let's say 20, our last token AB will be available at that. We will spend some time understanding how this event clock works, since it is very important for implementing correct timing behavior of a colored pertinent model that uses time in it. Let us now switch to CPN tools. What you see in front of you is a very simple pertinent structure. We have used the same structure in our unit number 2 videos, especially in video number 2 of unit 2. We have used the same user-defined color sets we used in the earlier video. Let me show you those definitions here. We have color set IN, capital I, capital N. It has two colors, A and B in it. We had also declared two variables, IN1 and IN2 of type IN. And we had declared another color set out. It's a product color set. It's a product of IN with itself. We have used IN as the color sets assigned to P1 and P2, and we gave P3 the color set I2, or assigned out to P3. So what we do next is we will add some time to this model. A time can be assigned to a transition. So we have different activities that are modeled as transitions. So a delay of that activity, or a processing time that this transition has, or the process that this transition represent has, can be shown as a delay on a transition. The delay can also be added to output arcs, and we'll show as to how these delays can be added. But before we do anything, we need to declare our color sets to be color sets that can have time on their tokens. To do that, what we do is we go and to our color set definitions, and those color sets that we want to make timed, or the tokens in them, we want to have time on them. We add a keyword timed at the end of this definition. So what we have done is we have made IN a timed color set by adding this timed keyword at the end. Let me also add this timed keyword to our product set. Again, it's not necessary that all the color sets that you have in a model are timed. You need to only add this timed to those color sets where you want the tokens to have timestamps on them. And we'll see as to how those tokens get their timestamps and what role do they play. So since we have IN and out both as timed color sets, we can now have stamps on the tokens belonging to this color set. For example, we can add a token to P1 with a timestamp on it. So I can write add +5. If I do that, what I'm doing is I'm initializing this place P1 with a token color A, and by adding this add +5, I'm saying that this token A will be available at time 5. Okay, when we say at time 5, how do we know what time do we have right now? This is determined by this attribute in the index which says time : equals to 0. So right now it says that the time, the global clock time or the event clock time, is 0 at the moment. Now every stamp on a token will be compared with this time over here in order to determine whether that token is available or will become available at some future time. So let me add some tokens to all the input places. I'm not going to add any stamp on it. I'll just leave it as it is, and by default it gets a timestamp of 0. So what I'm saying is that this token A is available in P1 at time 0. Similarly, I do the same thing with P2, add a token over here without giving it a stamp. By default it gets a stamp of 0 because this color set IN is a timed color set. So every token belonging to this set will have a timestamp on it. If I don't specify it, CPN tools by default gives it a 0 timestamp. Okay, now what we have here are two input places with tokens. They are timed tokens, they have stamps on them, and I can run this transition T1, fire it. If I fire it, let's just fire it and see what happens. So I pick the execute tool and I fire it, and what I see at the output is a token AA that has a timestamp of 0 on it. The timestamp remains 0. If this T1 has some delay associated with it, we can add that delay and rerun this model to see what happens to the output token. So let me rewind this model and assign a time delay to this T1. How do we assign a delay to a transition? Select it, hit tab key twice, and that's how we get to the delay region of this transition. You see this at plus highlighted. Let me assign a time delay of this transition 10. So what we have right now is a situation where a transition T1 has a time delay of 10 on it. And now I'll rerun this model, and you see at the output place a token AA has a timestamp of 10 on it, which means that the input tokens, since they were available at time 0, they were consumed by this transition T1. So this transition occurred at time 0, and since it has a delay of 10 on it, it created an output token with the delay 10 as a timestamp on that token. Okay, let me rewind it and just show you that we can also add delay to the output arc. And the syntax is as follows. We simply add this at plus and the stamp or the delay on it. So this way what I have done is I have a time delay of 10 on T1 and a time delay of 5 on the output arc. Let me rerun it and see what happens. Now I have an output token with a timestamp of 15 on it. So the delay of transition is added to the delay on the arc. It may not be very useful to have delays on arcs when you have only one single output arc, but if you have multiple arcs and every arc has a different delay, then you may like to use this delay expression on arcs. So let me rewind this thing and add different tokens to these places with different stamps to see as to how this timing works in CPN tools. 1A at plus 5. And so what I have is a token in P1 that is available at time 0. I have another token in P2 which will be available at time 5. And now if you look at T1 is not enabled. It does not show that it is enabled at this time. What time is it? We need to go and check the time attribute in the index. It says time is equal to 0. If we initialize our model using the simulation tool palette, you see that this transition has become enabled, but you need to look at the time over here. The time says 5. So what has happened when I click the rewind button, the global clock time jumped to the most recent time when a transition in our model can become enabled. The T1 cannot be enabled at time 0 because it has one token in P1 which is available, but it does not see any token in P2 because the token in P2 is not available at time 0. It will become available at time 5. So this transition T1 to be enabled, both these tokens must be available, and both of these tokens will be available at time 5. This is the most recent time when every input place has a token in it, and therefore the global clock time jumps from 0 to 5 because that's the next time anything can execute in this model. Now T1 is shown enabled. When I fire it, so remember that our global clock says 5 on it. If I fire this transition, I'll see a token at the output which has a stamp of 15 on it. Okay, we have a time delay of 10 on this transition. We do not have any delay on the arc. I removed it, and the output token says 15 on it. So how this 15 was calculated by CPN tools? Remember, initially we had a token in P1 with timestamp 0, a token in P2 with timestamp 5. The earliest time this transition T1 got enabled was time 5, as was shown by this attribute time. So at time 5, this transition occurs. Since it has a delay of 10, this 10 will be added to this time of occurrence. So 5 plus 10 becomes 15, and that's how the output token gets its stamp of 15. Okay. Let's play with more examples. Let me now put more tokens, more than one. So I'll put 1A plus 1B in P1, and I'll do the same thing, 1A plus 1B in P2. Since I did not specify any stamp on these tokens, the CPN tools default stamp of 0 is assigned to them. Let me rewind this. And again, since all the tokens are available at time 0, my global clock time stays at time 0 because this is the earliest time this transition T1 is enabled. Let me fire it once. When I fire it once, I see the output token AA at 10, which makes sense because the transition T1 fired at time 0 and had a delay of 10, so 0 plus 10 became the timestamp on the output token. Let's see what the global clock time says. It still shows 0 on it. Remember, the transition fired, it had a delay of 10 on it, but the global clock still remains at 0. The reason for this global clock to remain at 0 is that this transition T1 still has tokens available in P1 and P2 at time 0. So that's how CPN tools implement concurrency, things which can happen in parallel. Since all the tokens in input places were available at time 0, and this transition can fire at time 0 twice, once with A tokens and the second times with B tokens, it stays, the global clock stays at time 0. So let me fire this thing one more time, and you will see another token added at the output, which also has the same stamp of 10 on it. So this transition simply adds its delay to the occurring time in order to calculate the timestamp on the output tokens.